Problem 1 says the ratio of the small pyramid's height to the big pyramid's height is 4 to 7. So I want to compare their volumes. Okay, so the ratio of small to big is 4 to 7, but I need to know the ratio of their volumes. So to find the ratio of the volumes, I cube the ratio of their, in this case, their heights. So 4 cubed is 64, 7 cubed is 343. Okay, so 64 over 343. This represents the small pyramid's volume compared to the big pyramid's volume. Okay, and then I know the small pyramid's real volume is 320, and I want to figure out the big pyramid's real volume. Okay, so from here you can solve various ways. One method that always works is cross multiplying. So 64 times x equals 343 times 320, which is 109,760. And then divide both sides by 64. Problem 2, the right cones are similar. Okay, so I look for what are the corresponding measurements that I know, and for both cones I know the radius. The small cone's radius is 3, the big cone's radius is 12. So comparing them, I see that if I multiply the small cone's radius by 4, I get to the big cone. Okay, but I need their heights. I don't know either height, but I can figure out the big cone's height because I have a right triangle, so I can use the Pythagorean theorem. So 12 squared plus capital H squared equals the hypotenuse squared. Okay, so big pyramid's height is 16 centimeters. And then I know from the radius that the small pyramid's height multiplies by 4 to get to 16. So what times 4 equals 16? Well, 4 times 4. So the small cone has a height of 4. Okay, volume of the large cone. Formula for volume of a cone is 1/3 pi r squared times the height. So for the big cone, 1/3 pi times 12 squared times the height of 16. So this simplifies to 768 pi. Okay, volume of the small cone. So it's still a cone, so 1/3 pi r squared h. So for the small cone, radius is 3, height is 4. And this simplifies to, let's see, 9 divided by 3 is 3 times 4 is 12. Okay, then finally, what's the ratio volume of large cone divided by volume of small cone? Okay, so 64 to 1, but we should see if that makes sense. We figured out over here the ratio of the dimensions is 4 to 1. So to find the volumes, I cube both parts. and I do get 64 over 1 again. Right cylinders are similar. I know the volume of the large cylinder is 4,608 pi, but I don't know the radius or the height. Small cylinder, I do know both the radius and the height. So I'll start by finding the volume of the small cylinder. So volume of a cylinder, area of the base is a circle, pi r squared, in this case 9, and then times the height of 24. Okay, so this simplifies to 1,944 pi. Okay, so next I'll find the ratio of the large cylinder's volume to the small cylinder's volume. So this simplifies to 64 over 27. Okay, but I'm trying to compare not the volumes ratio, but the ratio of the heights. So remember, the relationship between the ratios is the volumes ratio is the cube of the, in this case, the heights ratio. So the ratio of the volumes is 64 over 27. So I do the cube root. Cube root of 64 is 4, because 4 times 4 times 4 is 64. Cube root of 27 is 3. Okay, so I know that the ratio of the heights is 4 to 3. Okay, so 4 stands for the big cylinder's height, 3 stands for the small cylinder's height. But let's use the actual measurements. The small cylinder's height is 24. So I match them up, they're both in the denominator. The big cylinder's height I'm trying to figure out. So now I'll cross multiply. Ratio of the weights of two spherical steel balls is 8 to 27. What's the ratio of their diameters? Okay, so the weight of an object is based on the volume. So we're really saying the ratio of the volumes is 8 to 27. So if we know the ratio of the volumes, that's the cubed version of the ratio of their, in this case, radius or diameter. So I need to do the cube root of the ratio. Okay, so what number cubed equals 8? Well, 2 times 2 times 2 is 8. Cube root of 27 is 3. Okay, so the ratio of their diameters is 2 to 3. Ratio of the lengths of corresponding diagonals of two similar kites is 1 to 7. What is the ratio of their volumes? Okay, so this time we're given a ratio of their, I guess, their edge length or diagonals. So to get from this ratio to the volume ratio, I need to cube everything. Okay, volume of the ratio of the volumes of two similar trapezoids is 1 to 729. What's the ratio of the lengths of their heights? Okay, so here I'm given the volume ratio, but I want the height ratio. So since the volume ratio is cubed, I need to get rid of it. So right now I'm at the volume ratio, but to get to the height ratio, I need to do the cube root. Okay, cube root of 1 is still 1. 1 times 1 times 1 equals 1. Cube root of 729 is 9. 9 times 9 is 81, times 9 again is 729.